In the New Mexico desert,
In the New
inside
Mexico
a national
desert,
park most Americans have never heard of, there is a stretch
inside
of
a
cracked,
national park
sun-scorched
most Americans
earth
have,
that looks like nothing.
like
No
nothing.
monument, no sign, no fence,
No
just
monument,
dirt,
no
baked
sign,
hard by decades
no
of sun,
fence,
sitting between
just
rolling white
dirt
gypsum
baked.
dunes that shimmer like snow in 100-degree heat. Tourists drive right past it on their way to sled down the dunes. Rangers used to walk over it without a second glance. But underneath that burned-looking crust of dirt is something that has quietly forced scientists to tear up the story they had been telling about the human history of this entire continent for almost a century. Buried in those layers of ancient mud are footprints, human footprints, tens of thousands of them left by real people who walked the edge of an ice age lake, carrying children, chasing animals that no longer exist, playing in puddles, living entire lives nobody thought were possible at that point in time. And when scientists finally figured out how old those footprints actually were, the number was so far outside the accepted timeline that a lot of respected archaeologists simply refused to believe it. For most of the 20th century, American schoolchildren were taught a very tidy story about how humans first arrived in the Americas. During the last ice age, sea levels dropped so low that a land bridge called Beringia connected Siberia to Alaska. Sometime around 16,000 to 13,000 years ago, small bands of hunters crossed that bridge, followed a corridor that opened between two massive ice sheets, and spilled into North America. These people are known as the Clovis culture, named after the town of Clovis, New Mexico, where their distinctive stone spear points were first found in the 1930s. For decades, this was treated less like a theory and more like settled fact. It became so deeply built into the field that questioning it could genuinely damage a young researcher's career. If you found evidence that looked older than 13,000 years, the safest move professionally was to quietly bury it or explain it away. White Sands National Park sits in the Tularosa Basin, a wide desert bowl ringed by mountains in south-central New Mexico, famous today for its blinding white gypsum dunes, the largest field of their kind on Earth. But during the last ice age, this basin looked nothing like the desert you see now. It was cooler and wetter, covered in grasslands and conifer trees with a large lake called Lake Otero at its center. That lake and its marshy wetlands were a magnet for life. Columbian mammoths waded through the shallows. Giant ground sloths, some taller than a grown man on their hind legs, browsed the vegetation. Ancient camels and bison moved along the shoreline, while dire wolves and American lions stalked the edges for anything slow or young or wounded. In the middle of all that ice age chaos, people were there too. Fossilized footprints had actually been noticed at White Sands as far back as the early 1930s, but nobody understood what they were looking at, and the tracks were largely ignored for decades. The real turning point came in 2009, when Park Resource Manager David Bustos began noticing strange depressions in the ground while walking the gypsum flats. He kept track of them, returning again and again, watching wind and rain occasionally expose new prints and bury them again just as fast. Bustos eventually connected with a team of international researchers, including footprint specialist Matthew Bennett, and together they realized this was not just a scattering of random tracks, but one of the largest concentrations of Ice Age human and animal footprints found anywhere on the planet. Here's a detail most people outside archaeology have never heard. These footprints are not something you can just walk up and look at like a dinosaur track in a museum. Under normal conditions, in the dry desert air, most are completely invisible. Researchers nicknamed them ghost tracks because they only reveal themselves under very specific moisture conditions, when the ground is just damp enough to create a subtle contrast between the compacted soil inside the footprint and the sediment around it. Scientists had to pioneer new detection methods, including aerial surveys and ground-penetrating radar, just to map where the invisible trackways ran before ever putting a shovel in the dirt. Excavated tracks are also fragile. Once exposed to open air, many erode within days, which is why the team worked fast using three-dimensional photogrammetry to permanently record each footprint before the desert reclaimed it. What they found preserved in that mud reads less like a scientific data set and more like scenes from someone's ordinary day, frozen in time for over 20,000 years. One of the most remarkable discoveries is a trackway that stretches nearly 1.5 miles, the longest known human trackway of its age anywhere in the world. Researchers determined it was made by a single individual, likely an adolescent or a small adult woman, who walked out across the mudflat carrying a young child on her hip, set the child down at some point, then picked the child back up again for at least part of the return journey. You can actually see the toddler's small handprints and knee prints in a few spots where the child was set down to rest or play. While that lone traveler was out on the flat, a giant ground sloth and a Colombian mammoth wandered across her path, leaving their own tracks over hers. And later, her return footprints crossed back over the animal tracks, meaning scientists could tell almost exactly how many hours passed between the two trips based on which prints were layered on top of which. Elsewhere on the same playa, researchers uncovered something even more dramatic, a set of tracks that appear to document an actual hunting encounter between humans and a giant ground sloth. Human footprints stepped directly inside the much larger, elongated tracks of the sloth, matching its stride for more than 10 paces. An uncomfortably long, stretched out gait for a person to keep up. At points, the sloth tracks show tight, looping patterns researchers call flailing circles, consistent with the animal rearing up on its hind legs and swinging its claws in self-defense. Meanwhile, a second set of human tracks approaches from the side on tiptoe, as if someone was moving silently to close in for a killing blow, while the animal's attention was locked on the first hunter. Whether the humans or the sloth won that encounter, the fossil record cannot tell us, but it stands as the clearest direct physical evidence anywhere in the world of Ice Age humans hunting now extinct megafauna. And then there are the smaller, quieter details, the ones that somehow feel the most powerful. Tiny footprints belonging to children, some barely old enough to walk, show up scattered across the site. In one spot, small prints cluster around a puddle that had formed inside a giant mammoth track, evidence that children were jumping and splashing in the ancient equivalent of a rain puddle, while the adults around them worked or watched the horizon for predators. In another spot, a small child appears to have knelt down and dug their fingers into the wet sand, leaving finger impressions that survived for over 20,000 years. One researcher described finding a print where an adult appears to have slipped slightly in the mud while shifting a baby from one hip to the other. These are not abstract data points. These are the exact same small, universal human moments that happen in every playground, in every parking lot puddle today, except they happened at the edge of a vanished lake during the coldest peak of the last ice age, thousands of years before the pyramids, before agriculture, before almost anything we associate with human civilization. Now, for the part that turned this from a fascinating local discovery into an international scientific fight. In 2021, the research team published their findings in the journal Science, and the headline number stopped the archaeology world cold. Using radiocarbon dating on the seeds of an aquatic plant called Rupia serosa, found in the same sediment layers as the footprints, the team calculated an age of between roughly 21,000 and 23,000 years old. To put that in perspective, that places these footprints during the last glacial maximum, the absolute peak of the Ice Age, when the Laurentide and Cordilleran ice sheets covered most of Canada and merged together, supposedly sealing off any land route into the interior of North America. If the dates were correct, it meant humans were already living deep in the American Southwest at a time when, according to the traditional model, no human should have physically been able to get there at all. It meant people had to have arrived even earlier, before the ice sheets closed off the interior corridor, likely making their way south along the Pacific coastline instead, a theory some researchers call the Kelp Highway hypothesis. The backlash was immediate, and it was not subtle. Archaeologists who had spent careers defending the Clovis First model pushed back hard, centering their argument on something called the hard water effect. Ruppia serosa is an aquatic plant, meaning it draws carbon not just from the atmosphere, but from the water and dissolved minerals around it. In certain lake environments, that water can contain old carbon absorbed from ancient limestone or bedrock, carbon that is essentially older than it should be. If that old carbon gets incorporated into the plant, it can throw off a radiocarbon date, making a sample look tens of thousands of years older than it actually is. Critics argued Lake Otero's mineral-rich water could have easily created exactly that kind of distortion, and that the true age of the footprints was probably closer to the conventional 13 to 17,000 year range. It was not a fringe objection. Respected researchers published formal rebuttals in peer-reviewed journals, arguing the original team had essentially fooled themselves with contaminated seeds. So the original research team went back to the drawing board. And this is where the story becomes, in some ways, even more interesting than the initial discovery. Rather than defend the original seed dates, they set out to independently verify the age using two completely different methods immune to the hard water problem. The first was radiocarbon dating terrestrial pollen from land-based plants like conifers, which get their carbon exclusively from the atmosphere. The catch is that pollen grains are almost impossibly light, so to gather enough mass for one accurate measurement, the team had to isolate roughly 75,000 individual pollen grains from the same layers as the original seeds. It was slow, painstaking work. The second method was optically stimulated luminescence dating, which measures the last time individual grains of quartz sand were exposed to sunlight before being buried, essentially reading an internal clock inside the sand itself, with nothing to do with carbon or plants at all. In October of 2023, the team published their results, again in the journal Science, both independent methods. The ancient pollen and the sunlight-exposed quartz grains landed on the same range as the original seeds, somewhere between 21,000 and 23,000 years old. Three completely different dating techniques using three completely different materials, all converging on the same answer. For many researchers in the field, this was the moment the debate genuinely shifted. It is far harder to dismiss three independent lines of evidence pointing to the same number than it is to poke holes in one. And the confirmations kept coming. In 2025, another team led by archaeologist Vance Holliday returned to the site and used quartz-based OSL dating on freshly collected samples from the footprint-bearing layers themselves, and once again the ages lined up with the original estimate. As one doctoral student on that team put it, seeing the prints in person and understanding their true age basically contradicts everything archaeology students have traditionally been taught about how North America was first populated. To be fair, the debate has not vanished entirely. A small number of researchers still argue there are unresolved issues, questioning whether some of the dated pollen could have been reworked from older, disturbed sediment, or whether the luminescent samples may represent maximum possible ages rather than precise ones. Science rarely settles anything with complete unanimous agreement, and that ongoing scrutiny is actually a healthy sign that the process is working the way it should. But at this point, the overwhelming weight of independent evidence, radiocarbon dating on two entirely different plant sources, plus an unrelated physical dating method on sand grains themselves, has convinced most of the archaeological community that these footprints really are somewhere between 21,000 and 23,000 years old, making them the oldest confirmed direct evidence of humans anywhere in the Americas. This single burned-looking patch of dirt fits into a bigger pattern most people never hear about. White Sands is not standing alone. In Chiquihuit Cave in central Mexico, researchers reported stone tools that may date back 30,000 years, though that claim remains heavily debated. At Cooper's Ferry in Idaho, tools dating to around 16,000 years ago again predate the traditional Clovis timeline. In the Bluefish Caves of the Yukon, animal bones bearing possible human-made cut marks have been dated to as far back as 24,000 years ago. And decades earlier, Monteverde in southern Chile already forced archaeologists to accept a pre-Clovis presence in South America roughly 14,500 years old, a finding furiously resisted for years before finally being accepted. White Sands did not create this shift alone. It landed on top of a slow, decades-long pile of inconvenient evidence the old tidy Clovis First story could no longer explain away. What makes White Sands different and arguably far more powerful as evidence is that footprints cannot be misplaced the way a stone tool or a bone fragment sometimes can. A stone tool can wash downstream, get mixed into an older or younger layer, or be misidentified. A footprint, by contrast, is proof of a living, breathing person standing in that exact spot at that exact moment in time. And it is directly sandwiched between datable material above and below it in an undisturbed sequence of mud. There is no ambiguity about whether a human being was physically present. The only real question is the precise age of the layer they were standing on. And that is exactly the question three independent dating methods have now answered the same way. If these dates hold up under continued scrutiny, and right now the evidence strongly suggests they will, the implications ripple far beyond one national park in New Mexico. It means the first people to reach the Americas likely arrived before the massive ice sheets sealed off the continent's interior, pushing researchers back toward coastal migration routes, people moving south along the Pacific shoreline by boat or on foot, long before any inland corridor ever opened. It raises real, unresolved questions about who these earliest arrivals were, whether they represent an entirely separate earlier migration wave or an earlier pulse from the same broader Siberian source population that later gave rise to Beringian groups. Some researchers point toward ancient North Siberian populations, related to remains found at a site called Yana, as a possible ancestral link, though direct genetic evidence connecting them to White Sands has not yet been found. Perhaps most strikingly, when this research reached tribal communities connected to the region, the reaction was strikingly different from the shock felt in academic circles. For many Native American oral traditions, the idea that people have been present on this land for far longer than colonial-era science ever acknowledged is not a revelation at all. It is simply a confirmation, in the language of radiocarbon isotopes and quartz luminescence, of something that had already been passed down for generations through story. Tribal partners working with the National Park Service on this research have described these new dates as validating histories their communities always understood to be true, even as outside science spent a century insisting otherwise. So the next time you hear about a scorched, unremarkable patch of desert dirt in New Mexico, remember what is actually sitting beneath it. Not just old mud, a mother slipping slightly as she shifts her child from one hip to the other, a toddler splashing in a mammoth's puddle, a hunter creeping forward on tiptoe toward an animal the size of a small car, an entire ordinary human day preserved by accident for over 21,000 years, waiting quietly under the gypsum sand for someone to finally notice it was there. And in noticing it, we did not just find some old footprints. We rewrote how long people have actually called this continent home.